I'll start the presentation. Good morning, good afternoon, everyone, and thanks for joining this session where we will see what Sheldon Cooper learns about JSON relational duality views. Before we start, a bit of introduction about myself. I work as a principal Oracle Cloud Technical Consultant at version 1. I'm also an Oracle ACE Pro, and I am a mentee in the MASH program. A bit about the MASH program: if you are looking to speak in front of public, then and you're afraid of speaking in public, then I would definitely recommend you to follow that URL given on the screen and get in touch with the right people there. There are mentors who can guide you with public speaking. Okay, so let's begin the session. So everyone knows Sheldon Cooper. He can be difficult at times, and he can be a difficult person to deal with. So one fine day, Leonard, Sheldon's roomie, asked him whether he has heard about this new feature, which is called the JSON Relational Duality Views. So as ignorant as Sheldon can be, he says, no, should he? So what are JSON Relational Duality Views? JSON Relational Duality Views are a special kind of view that has been introduced in Oracle Database 23 AI, which provides you the necessary flexibility and simplicity to developers to overcome the historical challenges faced with object relational mismatch. What is object relational mismatch? Well, as you know, traditionally in relational databases, the data is stored in normalized relational tables, which means the tables are related to each other through foreign key and primary key joins. Whereas in modern applications, more importantly, in the object-oriented paradigm, they include features or concepts such as object classes, attributes, inheritance, and associations. As you see in the screen, this is a code snippet from Java, where in a student class has been defined. So it might be difficult or challenging at times to convert these language objects to normalized forms, and vice versa. They need special kind of skill and effort to do so. So as expected, Sheldon asks, are ORM frameworks, object relational mapping frameworks, not supposed to mitigate those challenges? Yes, all object relational mapping frameworks do mitigate those challenges. They can simplify the application development, but they also introduce significant overhead, such as they need multiple database round trips to manipulate a single application tier object. They are not very good at managing concurrency control. They are very poor with batch or bulk processing, and at times there is always a possibility of divergent semantics across the modules and microservices, unless all of them share exactly the same mapping information. So how does JSON relational duality views address these problems? So with JSON relational duality views, you can store the data in relational tables. However, you can access the data in JSON documents. And these documents, JSON documents, can be generated on demand, and so that you get the best of both worlds, as in you get both conceptual and operational duality. Right. So Sheldon now finds this interesting. So how do we create JSON relational duality views? Well, say you have a department table where you have 3 columns: department number, department name, and location. And you have a constraint on department number, which is the primary key. So you can create JSON duality views using the syntax where you say create JSON relational duality views as select, then your JSON query, where your ID column represents the document identifier, which are mapped to the primary key. If you have a composite primary key, then you need to use a JSON object with the concatenated values of all the columns in the primary key. Then you can also specify the updatability of the document. By default, all the JSON relational duality views are read-only. You can define the updatability with the insert update delete clause there, followed by the with clause. Now, if you want to select data from your JSON relational duality views, you just say select star from your duality view, and then you have your data there. So as you can see, I have 2 records in there for 2 departments with the data in, as we see there. You can also pretty print your JSON data to make it more readable. So to do that, you can use the JSON serialize built-in function, and then you get the data for your JSON document in a more readable format. As you see, you also get, along with the data that you have created from the tables, you also get 2 couple of metadata columns. The first one being the e-tag column, which is used for optimistic locking, which we will see in the examples later in the presentation. And then you also get the system change number, or SCN, which is basically the logical or internal data, which stores the logical internal or database timestamp. Right. So at any point, if you want to check the e-tag value for your JSON relational duality view, you can use the sysrow e-tag built-in function and pass all the arguments. Pass as arguments all the columns that you have used in creating your duality view. So by default, all the columns that you have included will be considered for the e-tag calculation. But there are ways you can neglect those, which we will see in one of the examples after. So now we have seen how JSON relational duality views can be created, but Sheldon is asking that traditionally JSON needs a hierarchy. It doesn't seem to fulfill everything. So let's see how we can do that. So we have another table. Now we want to create a JSON relational duality view with the department table and the student table. So to do that, what we do is we create the duality view with the columns from my root table, which is the department in this case. And then I select the columns that I want to include from the students table in the form of a JSON array. So here you can, as I was saying in the e-tag calculation, by default, all the columns that you include in the JSON relational duality view definition would be participating in the e-tag calculation. In case you do not want any column to participate in the e-tag calculation, you can just mention them as using the keywords no check followed by the with clause, so that these are not included in your e-tag calculation. Also, you can specify at a column level using the with clause followed by no insert or no update or no delete clause whether you want a particular column to be updatable or not. You can both define it as at a table level and also at the column level. So now if I query the duality view, we will get the data. As you can see, we get the details of the department, all the columns from the department table, and also the student table as a JSON array. Now, you can also define flat JSON documents. To do that, what you need to do is you need to use the unnest keyword, which allows us to produce the flat document by unnesting the result of the scalar subquery. In this particular case, what we have done, we have created a JSON relational duality view called student unnest dv, where I have unnested the student information. So if I query the JSON relational duality view now, what we get is basically a flat document. As you can see, all the columns are at the same level. So in scenarios where we don't want the hierarchy to be present, we can use the unnest keyword. Well, so that is a fair question from Sheldon. He is asking, can we get calculated fields using duality views? Yes, you can. So JSON, there's a concept called generated fields that comes with JSON relational duality views. You can define specific columns to be generated from the columns which have already been used in the duality view using a SQL or JSON path expression, or a JSON or a SQL expression or a SQL query. By default, these are read-only columns, and this method of generating fields from with the help of expressions or a query is called inline augmentation. So let's see with an example how that works. So what I have in this case is we have an employee table and we have the department table, and I am creating a JSON relational duality views using both the tables. So here I have the column called salary within the employee table, which I am using here to calculate the sum of salary, minimum salary, and maximum salary for each department. So what I do here, I use the generated keyword using followed by the complete path of the column and then the function. So as a result, what we get here, as you can see, I have in the JSON document on the left-hand side, I get the maximum salary, minimum salary, and the sum of salary for each department. And if I compare that with a simple SQL statement on my employees table, I get the same result. You can also create hidden fields. Say for this particular example, what we are doing here, we need a column called total compensation, which is essentially the sum of your salary plus bonus. So we are tagging it as a generated column using salary and bonus columns. And in the output document, we do not need the salary and commission. So what we do here, we just use the hidden keyword, the column followed by the hidden keyword. So as a result, if I now query my view, it just shows me the total compensation. It doesn't show me the other two columns which I had used, which is kind of a handy feature. Now, we have seen some of the basic things about JSON relational duality views. Now let's see how these actually work. So I have a department table and a student table with 4 rows in the department table and 3 rows in the student table. So I have created a JSON relational duality view, and then I try to insert the data there using the view. So as expected, this will generate an error. Why? Because in this case, we haven't mentioned that the student table as we haven't tagged is as with insert update delete, so that privilege is not there. Now if we amend the duality view with that clause, then I can easily insert the document. So now if I go back to my tables and query the data, I will see that the data has been inserted into my root table, which is the department table, and also the data has been inserted into the child table for only the columns that were exposed in the duality view. Now, to update a document, you can update the entire document using a where clause, like so, where in this case, I am updating the location of department number 5, or you can use the JSON transform built-in function to update specific fields, like so. So if I now query the JSON, if I now query my department table, I will see that the update has been reflected in that table. Now to delete a row from the JSON using a JSON relational duality view, you can just say delete from your view with specific where clause that you need, and it will delete the documents, as well as the rows from the underlying tables. So Amy is asking Sheldon what he thinks. So Sheldon says that he has started liking duality views, but he's trying to find out how it handles concurrent transactions. So by default, document-centric applications sometimes use optimistic concurrency control to prevent loss of updates. So let's see how JSON relational duality views handle that. So what actually happens when you when I have a session which tries to update a JSON document, it first reads the data from the database, and then it creates a local representations of the unmodified state of the data, which is essentially the e tag and e tag column. Then in the second step, it changes or modifies or updates the data for the local copy, and then it checks the now concurrent persistent state, whether there has been any kind of update or not, or some other session or someone else has modified the data or not. If someone has modified the data while session 1 was trying to update it, then it readily raises an error. But if the persistent state matches, then it updates the record in the database, and then you can commit the data. So we'll look at that through an example. So let's consider if you have a look at the e tag information here for a particular document for department number 5. And what we are doing here, we are inserting doing a direct insert into the table student. We are inserting one record, and then we are trying to update the JSON document using the department student view, duality view. But if we try to do that, we will get the error saying that duality view cannot be updated as the value did not match the database. Value of e tag did not match the database. So if we query back, as we can see, there is a new document there, and the e tag indeed doesn't match. So what Oracle does here is Oracle uses the value-based e tag. Oracle e tag concurrency control is thus, we can conclude that Oracle e tag concurrency control is thus value-based or content-based. So any kind of conflicting updates can be detected and examined, and if necessarily, error handling mechanisms can be put into place. So now let's quickly look at how JSON Relational Duality View can provide schema flexibility. So suppose I have an address table, and therein I create a column which I define as JSON object. So when you create the JSON relational duality views, I define that column as a flex column. And now when I insert the data for, say, UK, where I have county information, I provide all the details and I can insert the data. So what actually it does is, if I now query the address table, I will see that the address ID has found a match and it has inserted the data in the primary key column. The country has found a matching column and the country has been inserted in the country column. But for all the other details, since there was no match found, all the details have been inserted into the attribute column. So in this case, to show you how it can be flexible, let's consider a record where I am trying to insert the data for USA, where instead of county, we have state. So if I now, as you can see, one row got inserted. And now if I query back the data, I can see that for the first record, UK record, I can see county has been inserted, whereas for the US record, I can see state. So this kind of gives you that kind of flexibility that you can leverage from. So Sheldon is very happy and he seems to be impressed, and he thinks that JSON relational duality views, it is a landmark capability that has been introduced, and it will serve great purpose to unify documents, objects, and relational models. So that brings me to the end of the presentation. This is a part of a bigger presentation. I will, when I share the slide deck, I will make sure that I include all the slides there. And if there are any questions, I'm happy to answer now. Or if you feel free to reach out to me on social later on if you want.